In fact, I've heard people say that when you do a modernization, you have to bring everything up to code, which is just not so. In most jurisdictions, elevators have to meet the code that was in effect when it was initially installed and at each alteration.
That sounds very complex, right? Let's say you've done 6 alterations, so you got 6 or 7 different code eras that you have to refer to. Is it just easier to say, if we're going to mod this, we're going to bring it up to current code? That way we don't have to think about 7 different versions.
Well, yes, it would be much easier if you did that, sure. There are some things probably that you wouldn't be able to change, but obviously the more alterations you make and the more you bring it up to the current code, the less of that chain of codes you have to keep.
Hello, and welcome to the Elevator Careers Podcast, sponsored by the Allred Group. I am your host, Matt Allred. Does your workforce need a lift? At the Allred Group, we are committed to connecting your company with top talent that matches your needs. Give us a call at 404-890-0445. Today's guest is Lee Rigby, an elevator code expert who has spent more than 55 years in the elevator industry as a mechanic, contractor, inspector, instructor, consultant, and now expert witness. In this episode, Lee shares insights from decades of interpreting and teaching elevator codes and explains some of the industry's most common misconceptions about modernizations and code compliance. We also discuss what years of expert witness work have taught him about the role safety practices and documentation play when accidents lead to litigation. Lee, welcome to the show.
Well, thank you very much. I appreciate the opportunity to be here.
Yeah, no, I'm excited to be able to talk to you. It's funny, I've been hearing your name for years, right? And then to finally get a chance to connect is something I've been looking forward to.
Me as well.
Awesome. Well, and obviously you got a long run. I mean, you said you got your start maintaining ordnance elevators on an aircraft carrier during the Vietnam era. And I'm just curious, what lessons from working in the middle of the ocean still influence how you look at elevators today?
Yeah, that was back in 70, 71. Probably the most important thing I learned was just perseverance.
Mm-hmm.
You know, when you're out there in the middle of the ocean, you can't just call for support. You can't just get a part in overnight or something like that. We had to figure out how to find the problem and fix the problem, even if we had to make our own parts.
Yeah, you've got to invent the solution sometimes, right?
Sometimes, yes, sir.
That's amazing.
Yeah, staying on task till it's resolved, I think, is the main thing I learned.
Well, yeah, there's no way to give up, right? It's like, no, we're going to keep plugging away and just kind of this confidence that, hey, there is a solution. We're just kind of leaning into it, pushing forward until we figure out something.
Yeah, and it served me well. When I got out and went to work as an elevator mechanic shortly after I got out of the service, I remember being on a Otis hydraulic job. And I'll tell you what, the Otis prints, I think, were made to be complicated so that it was very difficult for people to follow. And I remember staying up all night and half a day on a job trying to troubleshoot one electrical issue.
Wow. But you did. You persevered.
Yes.
That's awesome. You know, we talked a little bit about troubleshooting, creativity. I mean, that environment kind of forces that upon you, right?
Yeah, it did. Again, because it's difficult doing repairs at sea, it also helped me to learn about being proactive and preventing issues by adequate preventative maintenance.
Right. So obviously you've kind of moved into the code, and I'm just curious, you know, after 55 years in the business, what would you say is the biggest misconception that elevator people have about code compliance and maybe even modernization?
Well, the code is very difficult to follow. It used to be the codes were pretty simple, and I'll refer to them more later. But if you look back at the earlier editions of the code, this is the 1937 edition, it really got bigger in the 55. In fact, a lot of the rules we have in our A17 code today are word for word the same as in the 55 edition. But, you know, the codes are very complex, and it makes it very confusing for people who, unlike me, are spending all their time working on equipment and not actually in the code book. So it makes it very, very difficult for them sometimes to follow, figure out what the requirements are.
Sure. Well, you mentioned when we've talked before, just that because I asked the question, you know, at what point do you have to bring it up to code, and does a modernization mean you have to bring everything up? And you kind of said, not exactly, right? So
that's exactly right. But that's a misconception that a lot of elevator people have merely because of the complexity. In fact, I've heard people say that when you do a modernization, you have to bring everything up to code, which is just not so. In most jurisdictions, elevators have to meet the code that was in effect when it was initially installed and at each alteration.
So do you think that's maybe a response to that? That sounds very complex, right? Let's say you've done six
Yes.
alterations. So you got 6 or 7 different code eras that you have to refer to. Is it just easier to say, if we're going to mod this, we're going to bring it up to current code? And that way we don't have to think about 7 different versions and what those all mean.
Well, yes, it would be much easier if you did that. Sure. Then you just bring it up to the current code. There are some things probably that you wouldn't be able to change. The machine beams, they might have been installed under a different criteria and don't meet the deflection requirements of today's requirements. So there may be some things that you still have to refer back to the earlier code for. But obviously, the more alterations you make and the more you bring it up to the current code, the less of that
For sure.
chain of
Okay.
codes you have to keep. Yes.
Yep. Good point. Good point. And I was intrigued when I asked you to define modernization for me, because I've asked that question many times, right? What really qualifies? And I've heard, well, it's when you replace a controller. That's a mod. But what intrigued me the most was just how you responded. Obviously, that word gets thrown around a lot. Why would you say people struggle to define it, even some elevator professionals?
Well, probably because modernization isn't really defined in the code.
Okay.
The A17.1 code we use for elevators only has the word modernization in it in one place. That is in the definition section, but it doesn't define it. It merely says see alteration. And that's because anytime you change something such that it's more modern, usually means you're adding a feature to it. Anytime you add a feature that wasn't there before, it's an alteration. The problem is the definition of modernization, which is kind of, I think you asked me that. So I'd like to give you my definition.
Yeah, please.
And to do that, I have to give you some definitions out of A17.1 other than modernization, since it's not really defined well there. So we have maintenance, which is basically cleaning, lubrication, adjusting, keeping something as close as possible to its good working condition. Then we have repair. Something breaks, you have to fix it. You might have it welded. You might have to use an easy out and tap it, retap, redrill, tap. You may have to, do whatever needs to be done to repair something that's broken. If it can't be repaired, you have to replace it. Or maybe the repair of one thing means you got to replace something else to make that repair. So the machine's bad. To repair the machine, you're going to replace the bearings. Well, that's a replacement. Okay. So the definition of replacement is to substitute one component for another component that's basically the same for ensuring compliance with code. And that's not word for word, but that's basically the definition of replacement out of A17.1. So now we get to the definition of alteration. An alteration is anything other than maintenance, repair, or replacement. So if you're not doing repair, you're not doing replacement, you're not doing maintenance, then it's an alteration. Now it's a little bit confusing because some replacements by code are classified as alterations. So if you replace your controller, even though it's a replacement, it's classified as
and that's what I was going to ask. Yeah, because it seemed like controller. I mean, it's just going to control it, but to your point, it specifically defines it as an alteration.
That's correct. And there's a few other things that it specifies. You replace a hydraulic ram or cylinder, it's classified as an alteration.
Okay.
So there's certain things in A17.1 that says if you do this, it is considered an alteration, even though it meets the definition of replacement. So that's one reason why it gets kind of confusing. So now let's get back to my definition of modernization. My definition of a modernization is a series of repairs, replacements, and alterations. So if you're just repairing something, it's not alteration. If you're just replacing something that's not considered an alteration in the code, then it's just a replacement. But if you're altering something, then it's definitely an alteration. In A17.1, there's a section, 8.7, alterations. And in that section, it says, if you do this alteration, you must also do this, that, and the other.
Gotcha. So there's your series. Okay.
So there's a series. So if you replace the driving machine as part of your alteration, you must also add the auxiliary brake, unintended motion, that kind of thing. If you replace your controller as part of the alteration, you have to have a data tag giving you your minimum, maximum humidity and temperature ranges, which means you probably have to add air conditioning or do whatever it takes to stay within that range. You have to have your machine room have 19-foot candles of illumination. You have to have the 18-inch work clearance. Every side of the equipment requires access for maintenance. So there are things that are triggered by anything that's classified as an alteration. And when you do an alteration, you're supposed to, as part of the alteration, put on a data tag that gives the rule number for every alteration you're doing.
Oh my.
So you have to go through the alteration section of the code and say, I'm replacing the controller, I'm replacing the motion controller, I'm replacing the governor, I'm doing this, I'm doing that. Then you have to decide which of those are replacements. Okay, they go over there, and which ones are alterations. And everything that's an alteration has to have the 8.7 point whatever number on that data tag for that particular alteration. And that's so that when the inspector comes to inspect it, he'll know to look at the original code because that's already on the data plate. And then he'll see the alteration data plate and he'll say, okay, these things have to meet this code. That's why if it's a really old elevator, you might have the 1955 code for the original installation. And then you might have 1984 code for the alteration if it was altered in 1984.
Sure.
One of the big problems the elevator guys have is that the current code says you must put this data tag on. It shows the original installation code and then the code for each alteration. But if you've had a job that's been out there and been in service for years, how do you know when something was altered back in the day? It's almost impossible to go back and find those records.
Yeah. Well, and
you do the best you can. Do the best you can.
Yeah. I mean, it sounds like, a single elevator may have multiple tags and books and codes and different decades. And so I'm just curious, what's the most challenging code puzzle you've had to solve?
I think the most one that I can remember was the Citrus Tower. Now, in Florida, near Claremont, there's a tall building, and it's just a tower, just a small round building, and it goes pretty high. Is it round? No, I think it's square. It doesn't matter. But it's called the Citrus Tower. And when it was built, and for many, many, many years, you could pay to go up in the tower and get a huge panoramic view of the Florida countryside. And all you could see is, for as far as you could see, were citrus trees, orange groves, lemon groves, just everything as far as you can see. You go up the tower today, you can't see anything but houses.
Wow. Okay.
Completely. The only orange trees you're going to see is in someone's backyard.
Okay.
So when Florida adopted A17.3, which is a retroactive code for all existing elevators, an inspector went out there and he cited a whole litany of things that didn't meet code, including from A17.1 and A17.3. And so the building owners had called me, and I went out to assist them with seeing what their elevator had to meet and what didn't meet. And the big issue is what was the effective code for when it was installed, because there was no data tag.
Oh, wow. Okay.
And there was no records of any kind of when this elevator was installed. It was, back in the day, it was Otis. And it turns out it was installed before 1955. The problem they had was, since this tower was the highest building for absolute miles and miles, they ended up being the recipient of a whole slew of radio antennas and cell antennas and just all kinds of stuff on the roof. The tower is so small that the machine room took up the whole space at the top of the tower.
Oh my gosh! Okay.
So that means all of the equipment that's on the roof had to have the transmitters and equipment in the machine room, which the inspector wrote up as foreign equipment and had to get it all out of there, which of course would have been a disaster. And the room was too small to divide it into two rooms. But the earlier code before the 55 didn't have such limitations. There was no violation to have other equipment in the machine room. So we actually went back and had to go back into the county records to try to find when the building was built and the elevator was installed, which we did, which was pre-1955 code. So we just had those violations removed because they weren't really violations for that edition of the code.
Gotcha. No, that's
because A17.3 allows it to be there. You just can't add any new equipment into that space.
Okay. Gotcha. So how did you end up becoming the person that contractors, inspectors, states, attorneys call when they have code questions?
Well, after being in business, both as a mechanic and an elevator company owner for quite a number of years, I ended up selling my company to Montgomery Elevator, and me and my partner. And he went to work as a mechanic, and I went to work as a salesperson. And I was not happy there because I was not allowed, in my opinion, I wasn't given the freedom to do the sales that I wanted to do. And so I took a position with the state as a state field inspector. I worked out in the field for the Bureau of Elevators for 5 years. And then I had occasion to write a couple of reports on fatalities in my area.
Mhm.
of elevator technicians. And I did the investigation of those. I wrote reports, and the supervisor at the Bureau of Elevators in Tallahassee was impressed by my reports from what he told me. And so I got promoted to the engineer 3 position for the Bureau of Elevators. And in that position, I interpreted all the codes for the state of Florida. I represented the state on the ASME code committees, and I answered all the code questions for the entire state of Florida while I worked at the Bureau office. And I got really good at finding answers quickly in the code book. Somebody would call with a question. Back then, we didn't have PDF. So I had to open the book and I had to dig through the pages. But by the time I asked them a couple of questions about how the fishing was or the weather, or just, small talk,
Sure.
I'd just keep them busy for a couple of minutes. And then by the time I got done, I had my finger on the answer and I read them right out of the code book.
Right.
And it turns out a lot of these guys thought I was quoting it verbatim off the top of my head.
Maybe you were. Maybe you got it memorized.
Well, later on, I can, in some cases, I can quote rules off the top of my head because I've known them so well for so long, I can. But when I got started, I couldn't, but I could find them quickly. And that moved on into when I started giving continuing education for elevator inspectors and mechanics all over the country. And I had to do a lot of code research to find the changes in the code, to teach them the changes in the code and what the practical applications were. And because I'm giving this information to these people all over the country, they remember something from class and they'll call me and they say, hey, I think you said this in the class, but I have this problem. Since a lot of those questions come by email, I've accumulated hundreds and hundreds of email questions and answers. And I actually have a large email list where I will, if I get an interesting question and do a researched answer, because like I said, the codes are complicated. And on top of that, there's 33 published books of
Wow.
A17.1 interpretations by the code committees.
So in addition to the actual code, there's 33 opinions about what it really means. Okay.
There's more than that because there are more interpretations on the ASME website that have not yet been published into a book.
Wow. Okay.
But there's 33 published books of interpretations.
Right.
And many times when I give somebody an opinion, and by the way, if I give an opinion, I often put in there that these opinions are based on code and interpretations, but are not necessarily opinions of the AHJ.
Gotcha.
Make sure, because they have the authority to make their own interpretations.
For sure.
But I will very often, when I give a written interpretation or even over the phone, I will give a interpretation from the ASME committee that clarifies that particular issue in the code.
Yeah. So do you enjoy solving these code puzzles, or does it keep you up at night?
Well, I love it. I'm 75. I just turned 75.
Good for you.
I could have retired a long time ago. My wife's glad I'm not retired.
Too much energy. You're running around.
Much. I'd be around too much, So I'd still do expert witnessing, which does involve a lot of code research, and I still answer Q&A, and I send email blasts on questions and answers out to my industry list. I try to do it on a regular basis, and I just absolutely enjoy the research and digging deep into it so that I can, a lot of people, code people, consultants, so many times I've been asked, hey, this inspector, I asked him a question, he said this, is that right? And I'm like, well, it's right to a point, but no, it's more complicated than that. And very often when people ask, is this, can you do this or not? And I said, well, it's not that simple, because you just asked an elevator question, but they didn't tell me if it's a hydraulic or a traction or a rack and pinion. They didn't tell me if it's a new installation or if it's a, vintage installation or what year it was built. Is it glass back? Is it, that there's so many different factors that come in. Generally, when I'm asked a question, I have to give them more questions to get enough information to answer the question.
Yeah. What's the context, right? Because without the context, it's like, well, can't give you a full answer then.
Yes. Right. But it's fun and it's enjoyable and I love it. But the whole issue is that familiarity. I've worked with enough that like you said, I can quote a lot of codes verbatim, and I can clarify a lot of things that sound confusing. For example, the AE 17.1 for many years has had a rule under pits, construction of pits. And under rule 2.2.2.5, it says that all elevators with fireman service must have a sump pump, and the sump pump has to remove X number of gallons an hour. Now, that's all elevators with fire service. So what happens when you go to an elevator that doesn't have fire service or has fire service but much earlier vintage, and you modernize that elevator, and so now you're adding or upgrading fire service? Do you have to go back and add a sump pump? Because the code says if you have fire service, you got to have a sump pump. Does that apply? Yes or no?
Good question.
The answer is there's another rule in the very front of the code book that says this code applies to new installations only.
Oh, wow. Okay.
With some exceptions. The engineering section, I believe, is accepted. The A17.6, which is the maintenance section, is accepted. The alteration section is accepted. And the testing section is accepted. So there's various things that don't apply. So in order to find out if you have to go back when you add fire service, if you're required to meet 2.2.2.5 and have a sump pump, you have to go to one of those sections to see if you have to go back there. So you would go to the alteration section, look for adding or upgrading fire service, see what those requirements are, and see if any of those requirements send you back to 2.2.2.5, because otherwise it only applies to new. And
Gotcha.
guess what? There are none that do.
Okay.
So you don't have to upgrade. You don't have to add a sump pump just because you add fire service.
Gotcha.
And there's an interpretation that says that. So you don't have to just take my opinion of it. That's the ASME's code committee's opinion.
Yeah. There's a lot to it. And obviously you reviewed countless lawsuits, injuries, fatalities. What's something you've learned about human nature that maybe surprises you?
Well, number one is that memory is fallible. You know, a lot of people will say things in context of being deposed or something, and they don't really remember exactly what it was. People have a tendency to take the path of least resistance, and I want to delve into that a little bit. But when there's safety procedures to be followed, if people don't take the necessary steps to do things safe, there can be accidents as a result.
Sure. Well, I remember talking with a safety vice president, and he was kind of saying that weekend holidays, Friday nights, people are kind of rushing to get out. Have you seen that in your work as well? That this path of least resistance, and let's just get this over with, and we'll skip the safety procedures.
I can't say as I've really correlated that to any of the incidents I've been investigated.
Okay.
But I know from experience that is definitely a fact.
Okay. Yep. And you had mentioned that reading some technician depositions sometimes will make you cringe. What do you think are the most common mistakes people make, not just in the shaft or in the pit when they're doing the work, but when they're being questioned? You mentioned fallibility of memory, and maybe that's part of it, right? Is answering things that, that's not the way you remembered. Are you making something up? But what are your impressions on that mistakes when people are being deposed?
Yeah, if somebody says something that they don't know for sure, you need to preface it with "I believe" or "I recall," rather than saying this is that. And elevator guys should be aware of some things that I often find that they aren't aware of. For example, I mean, one of the major causes of accidents on elevators, there are a couple. The two major ones that are usually discussed are people tripping over the sill because the floor is not exactly level. The other one is being hit by the door. And door impacts, the door closing force and the door kinetic energy are regulated by code. And so every technician should know what the maximum door closing force is and how to determine whether the kinetic energy is within code or not. And I find many elevator technicians will say, yes, I've checked the door force. And what they mean is they put their hand on the door and they felt it stall, but that doesn't mean they read it with a gauge. Or they watch the door and it closes normally. And and I've read depositions where technicians say this. They say, yeah, I was there, I did the maintenance before the incident. I watched the door close and it closed normally. And they say, well, what is the requirement for the door? Well, I've just seen it so many times, I know when it's wrong, which is not really a valid.
It's hard to prove that in a court of law, right?
Yes, it's hard to prove that. But if the technician knew to say, well, the rule of thumb in the industry is if it doesn't close at more than 1 foot per second, and that door closed at 3.7 seconds, and it's a 42-inch door, which means 3.5 is enough, that means it's within code because it took longer to close than the 3.5 seconds.
So you talked about with the meter, I mean, and I don't think you're saying this, but is the implication that more technicians need to be checking with meters? I mean, because there's no way to know that the next person walking in is not going to get injured.
Oh, sure. But the spring gauge is adequate. You have one of those little gauges.
Uh-huh.
It's got a spring in it, and you just hold it at the door. I find a lot of guys don't really know how to use it. Most technicians do, because you can't read kinetic energy. And so anytime mass is moving, it creates kinetic energy. So in order to read the door gauge, you have to stall the door, apply the gauge, let it move the gauge. But again, there's movement. You can't read movement. So the way that the inspector's guide says is that once the gauge stalls the door, you back off on the gauge until the door starts to move, and that's where you read it, to read your force. Because otherwise you're reading kinetic energy.
So you wait until it actually pauses,
you stall the door,
and comes back. Okay.
You let the door compress the gauge, and then you back off on the gauge until the door starts to move.
Oh, interesting.
That's your static pressure force, which is your closing force, maximum 30 pounds.
Gotcha.
And then the kinetic energy is actually a calculation. But as I said, I wouldn't expect an average technician to do the calculations, because you have to know the mass of the doors and the mass of all the moving components of the operator and all that. But you don't need that if you know that the rule of thumb is 1 foot per second, and it takes longer than that to close your fine. Now, under the newer codes, all new operators have to have a tag on it marked in the feet, mark what the maximum door closing times is to stay within that kinetic energy force. And we find many times that the guys doing installations will put on that tag what the speed is. As a consultant, I've had it. I was a consultant for the city of Tampa, and we had a building with 4 elevators. They put new door equipment on all 4 elevators. All 4 were exact same doors, exact same operators. And if you did the calculation, they would all be the same as to how much what the minimum closing times are. Okay, minimum closing time. So the longer the time, the less kinetic energy. So, but each elevator had a different time on it, which isn't right. So, and what happened was, instead of doing the calculation and putting the minimum time on, they just put down the actual time that it had, whether it was right or wrong. So that's another place where it can be misunderstood what the requirement is.
For sure. Well, yeah, the requirement and the implication, and like you say, if it becomes an investigation, just knowing how important that one little reading would have been. Hey there, listeners, it's Matt, and I would love to know what you want to hear more of on the podcast. If you have a topic in mind or a guest you'd like to hear from, head over to elevatorcareers.net and drop a suggestion in the box, or you can email podcast@elevatorcareers.net. The link will also be in the description below. Thank you so much for being part of this conversation. Now, back to the show.
And then the next important thing is documenting it.
For sure.
If you're there doing maintenance and you happen to check the door closing force, it only takes 5 seconds, 10 at the most. Then before you leave, you should write that in the on-site records. Door closing force, 15 pounds or 20 pounds. And I can tell you what, that has saved a lot of elevator companies a lot of money. When I go out as an expert, somebody claimed they got hit by the door and it was too much force. They got pinned, it crushed them, whatever. And I go into the machine room, and the technician, when he did his regular maintenance, he put down door closing force, 20 pounds, door closing speed, 3.8 seconds. That just right there says the elevator company didn't do anything wrong.
Right.
So if we go back afterwards and we find it's the same as what the guy wrote down before, it couldn't have been out of code when that person got hit by the door.
Sure. Yeah, good point. But if they're not writing it down and not checking it, it's like your guess is as good as mine.
It's very difficult to defend a case.
Yeah, exactly. And
so, by the way, I don't work just defense. I work plaintiffs too. So, make sure you do it right, because I don't want to be on the other side of my elevator buddies.
Exactly. No, I mean, it sounds like you do deal on both sides of these investigations. And I'm curious, without naming any names, what's maybe one of those most unusual or memorable expert witness cases you've ever worked on?
Well, the fatalities are always the most memorable. Mm-hmm. And I've had a number of them, most of them being elevator personnel. Some years ago, the state outlawed what they called the knot style valve. I got one, but I don't have it here in my office. But it's a valve, shutoff valve, and it doesn't have a handle on it. You need a wrench to turn it. It's a cast iron body, and it has a bronze core that's cone shaped. So it's, the core is like this long and it's code shaped and it has a hole through it. And it goes down in that body. And if you turn it, it shuts off the oil flow. And if you turn it the other way, so the hole lines up with the pipe, then the oil flows through. But there's no seals in it. To make the seal, this cone shaped core has a threaded rod sticking out the bottom. You put a nut on it and you tighten it up. And when you tighten it tight, it seals that brass or bronze to the cast iron and it doesn't leak. And it's called knock style because if you want to open or close that valve, that's bound in there now because you tighten it down. You have to loosen the nut just a little bit and tap up on it from the bottom.
So it'll spin.
Just so it spins easy. Okay. And then you can turn it on and off, right? Well, the problem is that Dover was making hydraulic elevators and they came out with a valve that looks from the top and the side, it looks exactly the same, but there's no nut on the bottom.
Wow.
You just put your wrench on it and turn it. Well, the guys that are familiar with that valve, but not familiar with the knock style valve, they put the wrench on it and like, man, this thing's tight. And they'd force it, which would shear the threaded stud out of the bottom.
Oh, wow.
And then the pressure would blow that cone up in the air and the elevator would fall.
Sure.
Just as fast as oil would come out of the line, which is pretty fast, I can tell you.
Especially under pressure.
And so we had a case where an elevator technician was in a pit, and we don't know what he was doing because he didn't live to tell the tale. But for some reason, he was working in the pit, and that valve blew apart. And instead of laying down in the pit where you have a refuge area, he saw the car coming down, and he tried to beat it out by crawling out of the pit. And it ended up basically cutting.
Sure.
And one of the things that hit so hard for me on that was it recalled when I was a young elevator guy and I was working on an installation, and it turns out that when somebody put a pipe together in the machine room, this elevator was not past inspection yet. We were preparing it for inspection. But when they screwed the piping together, they didn't protect the components of the valve from being over tightened when they were tightening the pipe. So what they did was they threaded the fine threads that hold the valve together. So when we overpressured the system to get the relief pressure to prepare for our inspection, which was going to be the next morning, the valve blew apart. And it was oil rushing coming out, and it was gushing everywhere. And my first thought was, oh my God, this oil's going everywhere. It's going to destroy the flooring here, down the hallway and all this stuff. So my first thought was to stop the oil flow. The hoistway door was open. The machine room was on the ground floor. So I ran around and I jumped into the pit.
As the elevator's descending.
And as the elevator's descending, I jumped in the pit and shut the valve off. In retrospect, that was a pretty stupid thing to do.
I mean, a split second, you wouldn't have lived to tell the tale.
Yeah. It's so anyway, because of my experience, that particular accident, hit home more than some of the others.
I mean,
all of them are terrible.
Yeah. I mean, it's a split second decision, right? And
yes, sir.
It can happen that fast for sure. What would you say are, just kind of looking back at some of those challenging cases, what are some of the safety rules that people are most tempted to skip, and why is that so dangerous?
Well, the ones that they are, in my experience, and the ones with, injuries and things like that, the ones that are skipped most often are the safety procedures found in the elevator industry field employee safety handbook. They've got safety procedures, and the primary one is for safe access into the hoistway and into the pit, because there's a procedure to follow. It takes a few minutes. When you're going to get on a car top, you open the door, you put the elevator on stop, close the door, you set up a call, make sure the car doesn't run. You open the door, you put the car on inspection, take it off stop, close the door, make sure the car doesn't run. You also check the interlock to make sure the car doesn't run. So now you've got 3 different devices that will keep the car from running on normal. Then you have it on inspection and stop as you cross onto the car top. So you actually have 3 protections. The interlock's open, the stop switch is in the stop position, the car's on inspection. When you're crossing that threshold, going from the sill to the car top, you want to make sure that car's not going to move. For example, when I was a state inspector, this is another memorable one for me. To get on a car top, my standard procedure was to go to the second level, send the car to the first level, open the door, and get on the car top. These were short floors, so I didn't have to catch the car in flight to step on the car top. I just let it go to floor level, open the door, make sure nobody got in. And I'm standing there getting ready to put it on inspection, holding the door open. And the car just takes off and runs right by me at high speed with the door. I'm standing there holding the door open, and that car's just zipped by me at high speed.
Mm.
And I'm like, oh my God, I could have been reaching in there to hit the stop switch. Right. That's why when you open the door, you want to make sure the car's not going to run before you hit the stop switch and close the door to see if it's out.
I mean, it sounds like there's, like you say, there's three kind of safety mechanisms, checks, and if you're cutting corners or trying to hurry, you might expose yourself to some real risk.
You do. You absolutely do. In fact, when I do expert witnessing work, oftentimes there's more than one expert there when we examine the equipment, because you'll have multiple parties in a lawsuit, right? You have the plaintiff. There'll always be a plaintiff, otherwise there wouldn't be a lawsuit. They usually have their own expert. And then you have the elevator company, which is normally sued. Then you have a building owner, and sometimes the building owner and the elevator company are blaming each other, so they'll have their own experts. And now that so much of the elevator inspections across the country is privatized, I got a case right now where the elevator inspection firm is also being sued. So you got multiple experts on site. And I've been there, and I'll watch the other experts, and I'll often see them open the car top and just step on the car top without following procedures. I've had a number of cases where elevator personnel were killed in the pit because they didn't check the stop. They didn't turn the stop switch off, then close the door and make sure it wouldn't run with the stop switch in the stop position, and end up getting seriously injured or killed. So yes, those procedures are shortcuts. And another procedure that can take time, and people would be tempted to do a shortcut, especially with traction elevators, and that is the requirement that if you're going to do work that doesn't require moving the car, you're supposed to lock out, tag out the elevator, which means that on a traction elevator, if you're going to work in the pit and you're not going to need power, you got to go all the way to the roof, to the machinery room, remove power, and then come back down and do your work, and then go all the way back up to unlock it again. But that's really the safest way to do it.
Well, and you highlight that you're there doing an investigation. Maybe got 4 experts. If those experts aren't following correct procedure, they could end up doing the exact same thing or being injured, because safety doesn't prefer one or the other, right? Just because you're an expert doesn't mean you're not going to get yourself in trouble. So you have mentioned one of the biggest problems is poor documentation. What would you say separates excellent documentation from poor documentation?
Just providing adequate information. I've got a case right now where there was an entrapment caught, and resulting in a claimed injury. I'm not a medical person, so I can't say, whether it's, valid injury or not. But my job is to determine what the elevator did or didn't do, and whether the elevator was properly maintained, and that kind of thing. And so the record says that the technician came out and he found a bad communication between the controller and something else, and he replaced the board. That's it. That's all it says. What board? What caused the elevator to stop? What was the underlying factor here? And
so that's the documentation you have, and then so later, sometime you have somebody getting injured, and that's just not enough to go on, right?
Right. Well, it was injured just prior to this record, because this record was produced after the technician came out to find out why the elevator stopped. Okay. So the elevator technician came out. He didn't log any faults. He didn't say, oh, there was a power fault, there was a encoder fault, there was this fault or that fault. There's nothing. He just said that there was a communication failure and that there was a bad board. But he didn't say he replaced the board. He didn't say what board was bad. There's very little just for me to go on. Okay. Just the board and a board. Okay. And that really tells me nothing. And the problem is, of course, is that the lawsuits generally don't come in until just before the end of the statutes of limitations.
So I was going to say, it's long enough that
down the road.
You can't remember. That guy might not even be there anymore.
Yeah. Can't remember.
Very interesting.
Can't remember. By the way, when guys are being deposed, I mentioned that one of the things they do is say things that they're not sure of. But one of the things they need to know when they do a deposition is that you don't have to always come up with an answer. I don't know, or I don't recall, are perfectly valid answers. You don't look stupid.
It's better than making something up.
You don't know something. I one time was in a deposition, and this guy gave me a whole string of questions that were absolutely way off topic. And he says, well, do you know this? Do you know that? Do you know that? And for like 10 or 12 questions in a row, I said, I don't know. I don't know. And at the end of that, he says, well, you don't know much, do you? And I says, well, I know a lot. You're just not asking the right questions. So yeah, there's nothing wrong with saying I don't know or I don't recall. And if later in the deposition something they say triggers their memory, then you can say, oh, you know what? A while ago I said I don't remember, but you just said something that triggered that memory. Now I can tell you, and this is my answer. And of course the main thing I can tell anybody about giving a deposition is to tell the truth, because more likely than not, as thorough as the investigations go, if they find out the truth and you've lied, then it's you're in a lot of trouble. And you've done your employer a horrible disservice, because
Absolutely.
it's very expensive.
Well, Lee, I've got just a couple of questions for you as we wrap up. So first one, when you look across your decades of working in the industry, of investigating accidents and litigation, and what recurring lesson does the elevator industry still need to learn?
Well, I tried hard to teach code. One of the issues we have is that a lot of the technicians get most of their continuing education from the practical applications, which is very important. They have to know their job. They have to know how to fix elevators. They have to know how to do the troubleshooting. They have to know how to do all these things. But if your continuing education doesn't include a code component, you really need to do some investigation into that, and to know what the requirements are in your particular jurisdiction, because oftentimes your local jurisdiction will have revisions too, and Florida is no exception, but so are many other jurisdictions, that they will have amendments or deletions from the national codes in their local requirements, and they need to be familiar with those requirements.
Absolutely. No, it's a good point. Obviously, you've seen this industry from pretty much every angle: mechanic, contractor, inspector, code committee member, instructor, consultant, expert witness. Which role would you say has taught you the most, and why?
Oh boy. Each role has taught me a different facet.
Sure.
And so, the working as a mechanic taught me a lot about safety and just about perseverance and troubleshooting and that kind of thing. The expert witnessing is basically taught me what can go wrong, if you don't follow those procedures. The teaching helped to solidify and reinforce my code research that I learned while I was with the Bureau of Elevator Safety as a code enforcement guy. And actually teaching is probably the best thing that's helped me be a good expert, because when it comes to doing expert witnessing, the whole point of the thing is to explain to the jury in ways that they can understand, because elevators in the codes are very complex, like I said a number of times. And so if you can explain it in simple terms so the jury can understand it, it was one time where I had to explain a hydraulic elevator and how it works. And the expert for the other side said that, this happened on this hydraulic elevator. And I was trying to tell the jury that it just was not possible. And I actually had a Dover I2 valve, and I had it in my lap. And I had all bolts and everything loose so that I could disassemble it by hand.
Right.
In the jury box to the jury, and took the components and showed it to them and explained it to them and put it back together. And after the trial, when we won the trial, I was working for the defense. And after the trial, the jury was pooled as to why they went the verdict for the defense. And a couple of them said, well, we didn't know what that guy was talking about. He took that thing apart and he explained everything. But obviously he knew what he's talking about, and we believe him. So
Exactly. No, that's you got to have the credibility and knowing how it works, and all of that is so key. So each of those roles really combined, right? You couldn't do one without the other, right? You couldn't be an expert witness without having been a mechanic and done some of those things, at least not in the same way. So
correct. And I feel very fortunate to be in this industry, and very fortunate that I had the opportunity to wear so many different hats.
For sure.
And to learn so many different things. And that's another reason why, I'm semi-retired, but I can't give it up. And that's because, I think I still have a lot to share, and I'm very glad to be able to do that. And it's just my joy in life.
That's awesome. Lee, anything else you'd like to say before we wrap up?
Yeah, I'm doing a Riverkeeper paddle again, 107 miles over 5 days. It's a fundraiser.
I love it.
I'll be putting out an email blast asking for contributions, and a lot of my elevator people that I've known for years and have been able to call them when I needed something, or they called me when they needed something. And I appreciate everybody who's helping me with that. And I always try to give back,
For sure.
not only to the elevator industry, but to other places I can as well.
Right.
So,
No, it's awesome that you can do it. I mean, at age 75, you're still rowing 100 miles in 5 days. I mean, that's amazing. It's really awesome. Good for you. Well, thank you.
Thank you so much,
Yeah,
Matt.
no, thank
I
you.
appreciate your time.
I appreciate the time, your expertise, and yeah, thank you for all you do for the industry and keeping us within the codes. Thank you for listening to the Elevator Careers Podcast, sponsored by the Allred Group, a leader in elevator industry recruiting. Please visit our YouTube channel at Elevator Careers or check us out online at elevatorcareers.net. Please like and subscribe, and until next time, stay safe.